All right, welcome. This is kind of improvised. I was working on this. Actually, it's the Ensures. So having the Ensure work on the normal functions is fine. It is storing a return value and it executes that, and everything is fine. But for the macros, that's a different system and doesn't really quite work. But like working with this, I am so tired of the way it works. It's very annoying, and the first thing I'm going to do is actually is I'm planning on throwing away what I had. It's kind of working, but I this is the second time I throw away um, code that I started on to kind of fix this problem with the ensures. And instead, I will do some cleanup because I think there's some tech debt in this. Okay, I'm not going to work on the ASM statements, but there are things that can be done to simplify things here. For example, I have the asserts, and the asserts are kind of reused um, for the insurers and so on. Maybe they need to be fixed. I need some other way also to kind of simplify the code gen that I have to do. So I threw away the old things, and I'm thinking like right now I should just go through the code, see if I can find something that needs cleaning up, and you can come along for the ride. And as always, I will occasionally look at the chat, but not all the time. So, okay, here we have the standard compound statement. That one, I guess, looks okay. We're just going through those. It doesn't create new statements. That's fine. Okay. Analyze them, poison the AST, and then we say, okay, all okay at the end. It should probably poison the statement if it's not okay, but doesn't matter. So here the continue statement, it's fairly well documented, I think. This looks okay. Dive into an expression. So what does this do? This is, I think, inside of a you want to look at the last kind of expression to see if it has a particular thing, even if there are things like expression lists. And then you want to like look at the last thing that happened, and that there are different things that can happen. I wonder if this one is handling. No, it isn't. So if you have something like an to expression, then in this case, the last thing would be. I wonder about this. It kind of depends. This right now is just jumping into whatever pointer. Okay, into bool. The costs. Maybe it's okay. So catch in cond, right? And so the catch is you want to see if that last one is an catch. It's okay. Wrappable catch. I want to look at that. Defer, inline defers. It is always a problem because you want to inline things, and it's still not super nice to kind of inline things at some place. So it's like sometimes the thing that is annoying is that sometimes you just want to do something and you want to keep that as a value, like that you can copy around and test for, but then you have to create a temporary declaration before you do that. So that is the problem. So here is an optional. If this is a call, we should check against the return in that call. Yes, so the return. I don't know how to do that right now. So the RD is sure, so we're annoying. We can maybe do something nicer here. All right. Maybe here we do the grab the checks, and then we have to copy them. But there's okay, and then we do the analysis, which makes sense. That makes sense. Here's analysis on block exit. So you have a return in a macro. There are no expression blocks anymore, so they are just in max. I wonder if I could do the macros differently so that they I don't need these. Anyway, so here's if you know the block type. Okay, so let's document this one. So this is either in a macro. This should always be true now. So all right, so we have an assert checking, basically checking that it is a macro, right? And that's just this one, right? So now we don't have that variable. Okay, so great. So we have like check the right hand side if so we get inference, and this is kind of complicated. There are different things you can have, like the no match thing. It's not a binary, so you can't get expansion on the vectors. That's just that's okay. So you need to explicitly do that. And since this is always true, we want to do the checks so that it matches the opt returns, right? And otherwise, if there isn't a ret, then we are just going to see. Let's see that if there is a block type on how do we get the so the expected type. If the expected type is already void, or it is it's not a void and there isn't okay, so you can have an under return, but and you're not expecting void. So and this one should not be this. It should be like type is void instead. Testing for void is bad because otherwise it will not handle the case where you have an alias. So and this one can be a return CMA. So basically here, what if we already had well, the block type, hang on, it's the expected rate, had in an expected type, and we do an empty return, right? Okay, so now the exit reference is the same as the context exit reference, okay? Because we want to inline the differs, I guess. What do I use the block exit ref for? Yeah, okay, so this is all right. This is so that it knows where it's going to jump when we do the cogen. And then we inline the first, and if it's a macro, and it's going to be. So if this fails, then we are broken, and then we keep the returns. So we're going to add the returns, and the returns is what? Like, is the returns just the like these are the macro returns, right? It's not any return. So it's kind of bad to call it returns. So it should be perhaps renamed. Uh, you know, here we have some if returns, if it's an end jump, okay, returns, whatever. Uh, okay, and if it's a return, okay, we remove that return, right? So macro or block return, block returns. Oh, hang on, we have a returns cache even. What the heck? Right? Okay, no, we don't change that one. Okay, let's do this by hand instead. Better. Block returns. I thought we had some other uses of that. Okay, I'll have a look at the. Right. Okay, Wendy, you are asking me what's being worked on. I wanted to work on the ensures, macro ensures, the non-const ensures, but I got so annoyed with the code, so now I'm doing a code review, basically, fixing up some things. So unclear stuff. So here is we're going to change this, all these uses. So we have a kind of we have these returns in a block, and before this used to be like there was not just the macros. You had these block returns for the expression blocks. The expression blocks are dead now, so we don't have them, and then we can you know rename them block returns instead. Um, and and we can change all these places. Now I'm just doing this by hand, but I'm basically looking into like everything here and seeing if I can make it a bit cleaner without changing anything else. So it's not really adding any features. It's just going through basically the code and trying to see if something should be changed, improved, whatever. Okay, so that's the returns. I have no idea if the return cache is actually used. This could be some one of those like things that were never used in. I mean, yeah, look at that. Returns cache never used. Let's see if that's true. It might not completely be true, but it was not surprising. I was not surprised. So see. Oh, wait, what? This kind of broke something. Oh wait, I might have done something bad. Okay, so let's look at that. That was just renaming, and then I did something to the code here. So what did I do? If it's a macro. Oh wait. It's a macro. Um, that should always be true, right? So that should not change anything. And we're storing it, and we're doing if it's a macro or not, then we return false, right? That's the only thing. Um, Here we are doing the block returns. Yeah, we're changing to block returns. But what? All right, so let's see. So it expected a value, a return value of type void, right? And something went wrong there, I think. So did I? Yeah. Oh, wait. So, and it's not void. I changed it. Type is void, and it said it was not void. So okay. Now it's going to work better. Now just reverse the conditional. Um, yeah. Okay, and yeah, now it should work. While this is doing its stuff, let me continue. Right, and well, where was I? Somewhere with the returns. Probably, I have a Jello thing here. So clearly, okay, it's what? Right, this looks bad. If not warned, return success equals false. What? Okay, so let's see here. We have the current scope, right? We are the code is preventing executing. If we don't warn, then what? Because it's gonna be like it should be success equals false, and then go to end or something. Oops, go to end. Because there is this upper outer scope. No, we don't want to do that. We want to actually okay, if there's not a success, right, we have an error. Right, okay, so this should be okay. Right, we have success equals false, right, just that. And then we can go to end. Right. That looks okay. Let's stop this one and then this can continue running that. That was a bug, by the way. That was a bug. That could, like, it would create weird things as you do the analysis if that one failed. All right, so improve, convert this AI else negation. Do I don't do that? So okay, so I think that is done in LVM instead. There is no need to kind of do that here. Swapping them. Although, of course, it's always nice to do that because you do more analysis later. But yeah, I guess you can swap branches. So, like, if you find the negation is that the negation is oh, here's a reverse, right? This reverse. No, that's for each. I was thinking that was in the if statement. So, maybe I could have a look at that. So we are analyzing the cond, right? And we have a success. Assume we have a success, we can then look at what if the cond, the last thing is like a negation or not. Like it could be bool reverse is false, and then if it's a success, okay, so if it does seem unnecessary to do all this, like if it's more analysis, if it fails, if it's a success and cond cond expression kind equals expression unary, and cond expression unary expression unary blah blah blah. It's now a bit slow. Cond unary, and operator is unary not, then reverse equals true. Okay. Actually could just make that into the So once we get through all of this, like all of it, here at the end, if there's a jump on the contro, right, jump end on the statement, so what does this do? So then from catch else, right, and those kind of wraps will never happen anyway. So okay, it's invalid to scope. So these are not used anymore. And at the end, so if reverse now, if it is in reverse, then we can remove, we can override cond equals cond unary inner. There has to be also an else, right? And we should have an else body, right? Otherwise you can't really flip them. And then we can take this inner thing and overwrite that. And what more? And then we'll take the else body. How do you get that? So we have the if statement here, the statement, which is if statement. So the else body take statement if statement else body equals then statement if statement then body, and statement then body equals else id. Right. Oh wait, is that one? Okay, it's already there. So let's see that we don't do anything weird here. So if it's a success, there's an else body, and then we can do this with just tests. Like it feels like this should work, even though it's a bit weird. Branch condition evaluates. Okay, there's a then jump, which is false. Just let's make sure that that works. This is interesting. If it this, I don't know. I have no idea if this works. Yeah, it's running. A test runner actually compiles a list, so maybe this switch is done anyway on LVM CodeGen. it wouldn't surprise me. So it's kind of interesting. So let's see if the code gen is different. Let me see if any of you have any things. Say, okay, good morning. Programming without completion is hard for your project. You need to remember all the members. Find LSP broken more than often. So there are completions and some things are because, but so okay, so like the completions here, of course, this is just C, right? So there's nothing. Um, Nothing you see is we only have code completion for. I mean, we have code completion for C, as far as you can get it. I'm not sure what. I'm not sure I follow, but so far, boringly enough, this hasn't changed any code yet, and probably that won't actually. So I shouldn't really have done that. Let's look at that particular code gen for if. So emit if statement, and here we see, let's see here, if the cond is, let's see if it's a constant, then we just do that, and if it's not, let's see if I actually, no, it's actually, it won't do that, it won't do the flip, so we should see some things arising from this feature. Maybe I could just make a small test program to see if it happens. Like it's just compiling so incredibly slow right now. 300. We're never gonna see this. So let's see. We're gonna get debug stuff. Like get my file. This is gloriously good name. So we have a variable which is a, right? And we're going to do if a, and then we're going to print then a. Otherwise, we're going to print that not great. Print n b, right? So this is the normal thing, and we should see it printing the just b, right? Oh, could not be found. Print. Oh, I turned off the standard library. That's why it was unhappy. So I'm turning on the. I usually do that for debugging when I have to trace things. Now let's re-enable it. Let's see here. Right, so we get to B, right? And what I want to do now is I want to turn off this optimization that I did. So let's see what I have. Where is that? So the reverse, right? So and false. So now it won't happen. And oh yeah, of course I wanted to have this negation, right? Because that was the optimization. So if I have this and negation, and it should print a, right? So there we go. Okay, we can look at the code generated by this. So the box, right. So here is the not that one. I think this is. Oh, maybe it is. Maybe it is because there are so many bad things. Okay, so let's see if we can reduce this a bit by removing security and removing the debug output. So no safety. Yeah, this better. So we have if, right? So if we do then here we let's see here. So we go if it's equal to 0. Oh, that's the optimization, right? So and then we go to label if then and if else, right? And this is how it looks like. Now I turn on this kind of optimization, and does that give me something else? So can get a diff from here. Right, let me have a look. You can see this, but I can. And what do we see? Nothing. it absolutely did absolutely nothing to the code. So do we even reach this one? That's the question. No, I didn't reach that one. So why didn't I reach the reverse? Okay, so I guess it's a cond, right? And the cond is not, it's not going to match this. So it's a cond, and is an expression equals expression list, right? Expression, I think, list and cond expression list 0 is going to be that, and then this. Now it's getting a bit bad here. Like it has to be like this, and fixed size. Okay, so if it's a success, we do like this. If we have to do it differently. If success. And now assuming and cond is an expression list. In that case, if the reverse is equal to vex size of let's grab that expression list. This cond expression list. So if the size of that one is equal to 1, and then we get all this. So we get the list 0 as unary and list 0 as not. Like in all those cases, we get a reverse. So if we have all that, then we're not doing this. We like the expression list 0. That one is overwritten by expression list 0 unary expression. Actually, it can be overwritten exactly by that user. You can have. There's no need to do that. You can do like this. Right. This would work. Let's see if we get to this point now. Right, we do. Okay. Let's see if this breaks everything. Right. Okay, wait. I get an A. Okay. Did I get any new code, right? Did I change the no? No, nothing changed. Sadness. Okay. So we got here, right? We got to this point, and then we changed that particular node. Oh, No, we didn't get to this point. Again, we failed. So, right. Why did we fail? Did we get in here at all? No, it's not. It's not an expression list. So okay, what is it? It's a cond list. A cond list is an expression cond. Okay, so it's an expression cond. Cond. That means then let's see what that one does. In copying, it uses the cond expression, and the cond expression is a list. Okay, so it's almost the same thing. So cond expression, which will be const cond, please. Right. And now this might work. Oh, should have used a different one. But did I hit it now? We're still, I'm not sure that I'm hitting this code here. So let's make sure I do. Yeah, I do. And this one is a bit wrong. I shouldn't say expression list, it should say cond. But okay, we get the right thing, but do we have some new code now? That's the question. Do I compile it differently now? I'm like looking for this difference in compilation. I don't see it still. So, do we get here? No, we don't. We still don't get there. Right, so why? It's a good question, why? So I'm just going to stop here. I thought that was a unary expression, but apparently not. So let's see what the cond expression is, the expression list. So looking here at the first element of that particular list is an into bool. Into bool. Okay, so there can be different. Okay, the into bool thing is just, I think it has a negation on it, right? So it's into bool. Okay, looking here at how that one is handled. So let's actually jump for that one. Into bool. Into bool. Into pointer. Into float. Into int. Oh, it's almost sorted, right? Find usages. See how that looks like. Okay, so there's an into bool. There's a type, and there's a negate on that one, yes. So we have two of them, right? We have one is the unary, and the other one is the possible this into bool. Okay, I can probably always get this one, right? So should be safe to also say that this is true, right? And so then we switch over that particular list, right? So we have two cases where we are interested in doing the negation. So in the one case we have a unary. So case expression is unary, and then also reverse equals. So if the list 0 unary expression operator unary not not, then reverse is true. Okay, and then break, and then the other one is of course the case expression into bool. a negation on that, right? So if list 0 into bool expression, actually, the interesting thing here is it's the only case where it's interesting to do that change is not here, because there is no need. You'd get optimized thing regardless. So actually this was right. Bad me. Okay, so this was correct. It's just that I failed to take into account that that particular situation. So okay, so that was right, and I now need to have basically a bool here. So this bool is false. Now it's going to be hopefully changing those. So right. So let's first compile it without the without this one, with the optimization, or we can just basically say that we are in that. So and false. Right. So currently the compilation is like this. Then we see what happens if we compile it again. We turn it off. Stupid. Oh, it looks different. So let's look at that. So I can see if I can dock this one so you can see it. Like, no, apparently not. I can see that we are, losing one XOR. And but the weird thing is that it didn't swap those. So if not, like the else and the then are the same. Oh wait, the cogen was different. Okay, so this works. So okay, now let's fix those tests. It's a necessary fix. I mean, it's not super important, this thing, but I can remove this after that. So I should see some place where the compilation is different, but probably not many places. So let's see if you have any questions so far. Right. Okay. I was looking at the chat log. Thought about what was okay. Let's see here. So why is first evaluating positive case? Right. Okay. So right. The reason here, by the way, is that you want to remove the negation there to do more a different optimization, basically. When you do analysis on this one, you want to flatten it out as much as possible. So it's not important. It's not important. Just you can just reduce the number of instructions. So having a negation is unnecessary there, basically. But if you compare an int, then you're just doing an optimized, like compare it's 0 or it's not 0, and it's the same thing. So you don't have a win with a negation. mean, I could do this so that there is no else body, perhaps. That would affect more things. Like you could do, if not A, and do this, right? And make it work in that case as well. That would be interesting. Okay, so let's do that. So if there is no else body, it doesn't matter if there is an else body. Just do this. In this case, the then body is like going away, right? And so it should break. It should be a crash right now, I think, unless I actually handled that for some reason. Oh, I was like, okay, it's taking off a lot of time. Now let's see. No, that worked. And so let's. Oh, I turn it off. Yeah, of course it works if it doesn't run. So let's see, and of course all my tests I was running was on the one that I turned it off. So okay, right here we go. Right, it does makes total sense. So you're going into CodeGen the if one, right, the if statement. So and so you go in there, and then you have like a constant. Maybe you blur to the then block or whatever it is, but you should have something. So est not empty. So the then body here is not empty. Just with that. Okay, so here the thing is that it's just it could be so. See part 0. This is the right one, and also here we can just use that. It's a very it's just a bit fluffy here. So go like that. It's old code. So this is the correct thing. So we don't need else ID. We just want the else body. So this is one of the things that could probably be nicer in C3 if it was ever there. So let's see here. Okay, so we have if there, and now we kind of know things, right? See what happens here. I think the rest of it is probably like aware of what's happening. Yeah, we got it to work. So let's just see that if I said true, it works as it doesn't miscompile something completely crazy. Right. Okay, that seemed to work. If I take this to false and I kind of look at the code again, and then I'm gonna swap it over and disable it. So let's see what that looks like. So this is the CodeGen now, and actual the thing with is basically this one, right? So it's an if else, and there's an exit on otherwise, right? And we kind of changed it then. So and then if we turn it off and false, we're gonna have the same thing almost, but we're gonna have the negation in there. So let's see here. Right. And now we are seeing, like I can probably see this better in another view. Yeah, so what we do is basically we optimize away the not. So we drop that one. So if I have this now, let's see that it's enabled. Just gonna run the test now. So I can first run the standard library test. That's always useful. It shouldn't do anything. I mean, if there's something extremely crazy, then of course it will cache that. But probably not. The runtime tests actually, they usually pass. It's the CodeGen tests that are actually the ones that find the bugs for you, or the weirdness, or the ones that are affected by changes that you do to CodeGen. All right. So let's see if I get some changes here. Is extremely slow, right? It's just doing a few per second. Um, but that at least fixes a long standing to do on the if statement. It was a simple one. We could have changed other things, but right now it's like just the unary negation. When the unary negation actually matters, because as I said, if we are comparing pointers or something like that, we can just do a different comparison and we're fine. So swapping them and removing that negation doesn't actually help. But it does if we have some condition, usually from a function, then we can remove that negation and possibly get some leaner code. Even though things are, it's it will probably, the LVM will still rearrange things and stuff like that, but it's it's for the front end optimizations and analysis later, so I can just do that here. I wonder where this is invalid is here. Like, oh yeah, I think this is like if it is invalid, then we are not checking anything more. Like, so the current scope is invalid. That means you shouldn't really do analysis on the rest of the stuff. We do that for the if statements because an if statement could affect the variables, uh, the whether the variables are unwrapped or not, and then you get these errors because of the if. That's why I added it. I now remember. It's poison basically. So that was better. So scope is poisoned. Right. So let's see what's happening with the compilation. It's kind of worrying that I didn't get any difference in compilation. Right? It's really nothing here so far. I think, I mean, I didn't disable it again, did I? No, I didn't. But I think like maybe I'll quit here. If it didn't, sorry, if it didn't really change any of my tests here, sorry, um, sorry for that weird sneeze. If it doesn't change anything, then I probably will not keep this. I want to see that it actually changes at least one place and optimizes that. Otherwise, that added complexity is just worthless, to be honest. And just produces code that is a little different from what it should be. So I am guessing that the LVM code, yeah. Oh, sorry about that again. I can just do that optimization by the way in the CodeGen. So, well, there it is. Whoa, initializer list with subarrays. Finally, I have something. Thank you, thank you, thank you, thank you. It's giving me a little different code in this one. So it was subarrays. This CodeGen here, it just changed a little bit. So I am going in here. Now you can see all the windows. I don't think you can see all the windows, but so what I'm doing is, okay, it's there. I see the XOR, not XOR, so the knot there. Actually, the knot is an XOR. So and that happens in like one place. There's a poor if statement somewhere that actually does this. Yeah, I see it. It's a ball. Right. Let's see if we find something else. So that was the subarrays. And nothing else. So it was literally just one place. At least so far, there are about 100 tests, more tests to run. But you know, I'll keep it, I guess. Maybe can be used for analysis later. So. And almost done now. Right, this is not going into the release notes. It's just a refactoring. 100. When do we reach? Oh, we're already in 109 tests, right? Okay, so all of that. Actually, there was some other changes that we did with like the block returns and actually fixing up some things, the naming and stuff like that. So not completely worthless. So refactoring and what's we call this? The other thing like optimize negation in if statement, right? And I push that one. So there we go. Thank you for watching. I don't know if there are. So why are the codegen tests so slow? Right. So it's because it's restarting the. It's actually creating, loading the compiler, running the compiler from the beginning, over and over again. Right. In starting it as a separate process, and then getting some LVM output. So it's actually real running LVM as well. Finally using that output to verify things. So if you have there are the semantic tests, which are the C3, not just C3, they're just running the front end. So that one, those are much faster. But the tests that are doing codegen are essentially doing the whole codegen thing. Maybe I could, turn off the actual object files, object file. But I want to test the whole thing. So they are doing, as if you would compile it. So it's useful in that regard. So it's gonna be slow, but and that's because I didn't want to do shortcuts because that will test less. So, but there you go. Feel free to try it out. These changes. I should have run the test all at the end, didn't I? Oh no, that was the wrong one. Sorry. I meant I should have tested this one, the standard library, in unit tests of the standard library. And it says, oh, pass. Right. Good. Thank you for watching and have a great day. Goodbye. Oh, sorry. Integration with test of valid makes sense. Any thoughts on the tooling AST question? Looking back at chat, what would the best way for tooling to play an AST? Using compiler intermediates or bulk building and so on. So we talked about this before. People want to reuse the compiler because it's already parsing, right? The AST. But if you look at what IntelliJ does, is it builds its own tree, and that makes more sense because you want to handle incomplete stuff like the compiler, but not completely um, completely done. And if you want to have more information, even if you fail or code completion as you do things, then you have to do like this partial, you know, cache things and then try to do partial evaluation and so on. And you want to try to kind of insert things so that you can compile as much as possible, because otherwise you can't really have the code completion working. And I think that's a different problem from making a very, very fast compiler, because something that is caching the results and then incrementally updating that state, that's a quite different design. It can be very fast because it's like feel very fast because it's doing amortized analysis. So it's going to do like small update part and do the analysis on that part that updated. And um, the way it works in IntelliJ is that you have this huge cache of everything that you kind of parse and analyze, and then when you do an update, you need to, when some part of the code is updated, you need to figure out, okay, how does this affect the other code, and what other code do we need to update? So you kind of do a analysis on a dependency analysis between the files and even the parts of the files. And I mean, the compiler isn't doing anything like that. It doesn't have a cache like that. It just would be very complicated to maintain that. It wants to do a different analysis, maybe more than the IDE can do, but and also in a different way. So I I notice that LSPs are often not very robust. Yeah, so that is a well known problem. You know, yeah. So the main difference, yeah, the caching, incremental updating of that cache, and it's very hard to, handle a you have a code base where you have some no sorry you have data that is mutating, and then you have to do some analysis on it, not to in order to get the to get some information from the same code. And either you build the whole compiler as an LSP from the beginning, and I knew about this as a possibility, but I didn't want to do that. I didn't want to, lock myself into doing that and all of that. And I also think that the way the IntelliJ has been able to innovate on in terms of actions taken and analysis done on languages that is independent of the language. So it doesn't matter what compiler you have, it works anyway. So building it into the compiler would kind of say like there is just one compiler, right? Because everything else will not have anything, the LSP goodies. And if you have an external LSP, right, an external LSP will have the problem of re-innovating the things that IntelliJ, for example, does. So the IntelliJ has a lot of help for you to cache information. It has, giving you partial AST nodes and so on. It gives you a lot of that for free. And if you are writing an LSP, you kind of have to emulate all that machinery, and it's hard to do that well. That's why it's fragile because it's written from scratch every time. Whereas an intelligent plugin will might crash, but there's everything, even the crashing is handled fairly gracefully. So writing else basically the bottom line is writing LSPs and like at least as you add features to it, it's a quite complicated piece of machinery, and so I understand people want to do that because they want to bring it to all of the different editors that they like. Um, but I don't think you can get like you can get something good but not kind of great with the LSPs. So I hope people will continue working on LSPs, but it's a hard task. It's nothing that you can quickly kind of get into a really great shape. It's almost like a compiler. Now, actually, the difficult thing writing a compiler is not writing the compiler. It's writing the compiler while designing the language. Because if you start with a spec, you kind of know what what you need to handle. Whereas if you when you write the compiler and do design, you don't quite know what you need to handle, and then you have to rewrite things. And that's the problem for LSPs too, right? They're not able to work from the spec because the spec is not done, and so they kind of have to work from the known grammar, but then they don't know exactly behavior, and the behavior is needed to in order to correctly model everything. So those are my thoughts. It's going to be hard making an LSP a good LSP. I mean, a language should probably not. There's enough effort to just write one LSP to go around, and several LSP. If someone writes a new one, it's probably not going to be that good to begin with. It takes a lot of time. So your anticipate in a future rewrite. Not really rewrite of the C3C compiler, but I knew that, for example, the Go compiler, because it had a spec, people could actually write Go compilers without having to use the original Go compiler from a spec. And I want that for C3. It's a like a sanity check. It's a health check. You don't want uh, you can use like C3C as the oracle of sorts of what is supposed to work, but the spec is the real implementation. So I would like people to write other implementations of the C3 compiler. That would be awesome. Re-implement C3, um, and that's why it's important to also like C3 with some subset, maybe a C3 compiler just targeted at embedded. Maybe someone needs to do and like try to keep the semantics clear enough and simple enough that you could actually rewrite it for your particular thing, so that you write a C3 compiler just as you can write a C compiler today. The C compiler, there are some things that it can gnarly. It's like the preprocessor and those rules. So can I make, we have a lot of features in C3, but can we make it, not much harder to implement than C? Then I'm very happy about that. So that's what I want. Make it re-implementable. Any questions? Any other questions? Otherwise, I'm just going to grab some lunch now. It's 1:45. I get like giving you 3 seconds. All right. Thank you, everyone, and have a great day.